So I realize it's been slightly distracting at my house lately. So I've gone out at night into the forest to record tonight's video. This video series follows the biology coloring book by Robert T. Griffin. Well, today we're going to learn about the properties of enzymes and about enzyme action. So here's a match, and let's say you want to have some kind of fire to keep warm, to keep warm. So you light this match. Now this, as you know, is a chemical reaction. However, take a look at this bunny. This bunny is a whole mess of chemical reactions, thousands or millions of chemical reactions happening every second of every single day in every single one of its tiny little bunny cells. So how come this bunny is not on fire? That's what we're going to explore today. Well, enzymes are the reason. Enzymes are the reason that all these chemical reactions can take place inside the cells of your body without lighting you on fire. Enzymes are protein catalysts. They're made of protein, they're catalysts, they help chemical reactions take place, and they do this by lowering the activation energy. They reduce the amount of energy needed to get the reaction started. And they help make reactions take place at safe temperatures so that you don't have to worry about a bunny spontaneously lighting on fire, unless you want it to. So let's think about an activation energy as being like this big hill where I have to push this rock over the hill to squish this bunny. So this hill is the energy that's required for me to be able to squish the bunny. That's how much energy I have to put into the rock in order to get it to roll down the hill and squish the bunny. That's an activation energy. That's the energy that's required for me to get the job done that I want to do. So enzymes have activation energy too, and the reason they do is because we start with reactants, and eventually we get to products, but in between the reactants and product stage, there's the transition state. And that's where the bonds, the chemical bonds between the bits of the reactant are being broken and new bonds are being made, and that takes energy. Now, one source of energy is heat. You could just heat something up until those bonds break and the new ones come about. Or you could use an enzyme. So an enzyme actually reduces the amount of energy that's needed for the chemical reaction to take place. See this dotted line? That's the activation energy with an enzyme. That tells you that there's less energy needed to get this reaction to take place. So maybe the heat that's inside your body is enough to make this reaction take place. You don't need to do anything extra. You don't need to add or increase temperature to make it happen. In order for enzymes to work, three things have to happen. First, the enzyme has to physically bind to the reactants, which are often called the substrate. They do this at the enzyme's active site, which is a special region of the enzyme that is shaped to fit a particular substrate. When the two bind, they become the enzyme-substrate complex. And this is where step 2 happens, where old bonds are broken and new ones are created. Once the new bonds are created, the enzyme moves to step 3, which is just releasing the product. Here's what this looks like over time. Step 1, the substrate enters the active site. We used to think that the active site fit the substrate like a lock does a key. But now we think that the enzyme actually changes shape as the substrate binds to it. Step 2 is the enzyme-substrate complex. That's where the enzyme is going to break the bonds of the substrate and create new ones. At step 3, the products are released. And this can happen over and over and over again. As long as there is substrate, the enzyme will work to produce the products. Enzymes don't get broken down by the chemical reactions that they take part in. That's what part of being a catalyst means. They help the reaction taking place, but they don't get broken down or used up themselves. Enzymatic reactions can be inhibited. So here's a reaction that's happening as it normally should. The substrate is binding with the active site. The enzyme breaks the bonds in the substrate and then releases the products. Now, what happens when there's too much product building up in the cell? That wouldn't be a good idea for the cell, because then that might interfere with homeostasis. So cells can turn enzymes off through a process called inhibition, and it looks like this. In this case, the cell produces an inhibitor, and the inhibitor takes the place of the substrate at the active site. And as long as the inhibitor is there, it competes with the substrate for the active site, which means that the chemical reaction slows down, or sometimes stops altogether. So when a cell wants to turn an enzyme off, it can produce lots and lots of inhibitor molecules that stop the enzyme from working. Here's a few more details about enzymes that you need to know. In general, one enzyme fits one substrate, which means that an enzyme does one specific task only. Cells often use inhibitors to regulate enzyme activity, and you can slow an enzyme down by increasing the amount of inhibitor that is in the solution that the enzyme is working in. But enzymes are also affected by things like temperature and pH and other factors. We're going to explore these factors in a lab that we're going to do next week. That's the end of this video. Please complete the corresponding review questions and be prepared to show me your notes in class. And as always, here's your bunny of the day.